Hello, Shoyan here. The framing is complete and the exterior load-bearing walls are up. Today, I'm fastening the hardware, insulating the foundation, and then laying the subfloor. I'd hoped to show you the framing process, but capturing it with our current skills and equipment at the site is a challenge. To avoid inconveniencing the client and contractor, we weren't able to film it. Thank you for understanding. I'll start by fastening the hardware. First up is the hold down at the bottom. The hold down bolt is embedded in the foundation and connects the foundation to the columns. When securely fastened, it keeps the continuous column on four corners from lifting. Both sides of the load-bearing walls act as diagonal braces, and the hold down is used on most parts. This keeps the building anchored to the foundation even under vertical movement. While anchor bolts stabilize the seals, they don't fully prevent the structure from lifting. The exterior walls act as diagonal bracing to prevent sideways shaking. With today's hardware and load-bearing walls, the building is secure. Since this home meets long-term housing standards, more hardware is used than usual. Next, we insulate the foundation. This house will be fully insulated and airtight, including the foundation. There are two methods for airtight construction, either sealing only above the floor or sealing from the foundation up. This time, the entire house will be airtight and insulated, including the crawl space. I start by attaching 50 mm thick insulation to the foundation rise using silicone adhesive, in other words, caulk. Caulk is often used to seal the gap to prevent leaks, but it also works as a glue. I also insulate the bottom concrete slab, extending 60 centimeters from the foundation. This helps prevent heat transfer. In summer, the foundation heats up, and in winter, it cools. This insulation stops both heat and cold from seeping into the building. This insulation is dense and heavy. I don't know why, but it can only be cut from one side with a box cutter. When I used a circular saw to cut pink styrofoam insulation in the past, it created a mess of light dust that was hard to clean up. In contrast, this insulation creates heavier particles like sawdust that fall to the ground, so it was easy to clean up. Higher density insulations, whether fiberglass or foam, tend to be more effective, but they're also more expensive. At the corners, I apply a thin layer of polyurethane foam spray to seal any gaps, making sure it's well insulated and airtight. Using the spray foam gun takes a bit of skill. A 7 mm thickness is ideal, but achieving precise control can be challenging. Next, I seal around the airtight gasket between the insulation and the foundation. Using the urethane foam above this gasket ensures complete insulation and airtightness. Out of the blue, I started cutting the PP strapping. It's not for waste sorting, but to use when I move on to laying the subfloor. The subfloor is supported by 90mm square beams connected with a joint similar to a dado joint, with some areas notched. When everything is joined correctly, it works well. But occasionally, the pre-cutting machine makes a notch too deep, and it causes a slight step under the 24mm thick plywood panel. To level out these steps, I add 1 or 2 layers of PP strapping. While I can't adjust every joint perfectly, I make fine adjustments where I can. I secure each beam with 2 long nails. Some time ago, I worked on a different building with a floor structure that used joists. In that building, just a 1mm shift in a joint of the beam and sill caused low creaking sounds. So instead of using nails in specific areas, I'm nailing around each beam with 2 nails throughout to prevent any floor noise. Next, I check the height of the beams. I could use a laser level, but I mostly rely on a piece of string to adjust the height. Lasers are accurate, but for this work, string feels more reliable. Maybe it's just a traditional carpenter's preference. I slightly raise the floor in the middle by the thickness of a string. The floor won't sag as long as the wood doesn't shrink, especially if modern metal or plastic floor posts are used. Wood can sag over time, but the posts help support it, so raising the middle of the floor by about 1mm helps balance it out. I often add adhesive just for precaution. Now the frame is mostly complete, but the plumber hasn't finished the piping yet. I also can't work on the beams where the structural plywood is stacked. So I lay down 2 or 3 plywood panels in areas that won't interfere with the plumber's work. Then it's some extra work, but I move the stacked plywood to work on the framing in those areas. The plumber will install the pipes tomorrow, and then I'll lay down the subfloor plywood the following day. The structural plywood needs to stay dry as moisture can warp it. Since the windows aren't installed yet, I cover them with sheets for protection. With the plumbing complete, I can start laying the floor. Before installing the subfloor, I notch the sill where the door frame will go. The bottom of the door will be about 60mm lower than the sill. Since I can't use a circular saw after the plywood panels are installed, I notch the sill beforehand. These days, entryways tend to have a smaller height difference from the main floor, so door frames are usually mounted higher. Typically, sills aren't used for front doors, but for this house, there will be a 60mm step between the floor tiles and the main floor. Finally, I start laying the plywood panels. Since this house is insulated from the foundation and is airtight, there's no insulation for the floor itself. Floor insulation is a bit risky because someone could accidentally step on it, fall through, and get injured. I secure the subfloor with 75mm end nails. Technically, the plywood used for the subfloor doesn't require end nails since it isn't part of the frame, but they are needed for the second floor and the attic's horizontal trusses. To ensure airtightness, I caulk around the columns and studs. It's better if any air leaks occur inside the house rather than into the walls, which connect to the crawl space. Air leaks in the walls could negatively affect the results of the airtightness test. I fastened the hardware after the framing, insulated the foundation, and installed the subfloor. It's much easier to move around. That's all for today. Thanks for watching.